All right, welcome back to the virtual residency workshop for 2021. This is day 4, Thursday, June 10th. This is the second session of the day. It's our panel on ethics and privacy in advanced research computing. Our moderator is Melissa Cragen from the University of California, San Diego and the San Diego Supercomputer Center, and I'll turn the show over to Melissa.
Great, thanks very much. So welcome everybody. Our panel today at this point will be on ethics and privacy in advanced research computing. We've got a group of 5 experts from various areas. I will introduce each of them ahead of their presentation. The plan is for about 10 minutes of presentation, and then we have plenty of time for Q&A and discussion. I have dropped the link to the session's Google Doc in the chat. I will tell you that I am notoriously bad at managing a Zoom session and being able to monitor the chat and note-taking. So I welcome all of you should have access to the notes. Please feel free to add your thoughts and comments. And we appreciate that. So this session really is going to extend beyond. There was just a great discussion on AI and trust at the end of the last panel session. And we're going to be shifting, we'll include AI in this panel, but we'll shift a little bit more deeply into the ethics and privacy area and responsible research and specifics around handling data. My thought here is that both in terms of AI as we move forward and ethics as we expand the work that we're doing in computing services across campuses and including professionals in the data space as well on our teams, we need to be sort of thinking more broadly about what we need to know and how do we include some of these new kinds of things like GDPR, for example, in our thinking about how we work with faculty and students on their research. Okay, so to kick us off will be, and I'm sorry, I'm going to read their bios because it's important for me to get all these details in. Julia Stevanovic is assistant professor in the Department of Computer Science and Engineering at the Tannen School of Engineering and the Center for Data Science at NYU. She is a recipient of the NSF Career Award and NSF CRA-CI Fellowship. Julia's research focuses on responsible data management and analysis practices, operationalizing fairness, diversity, transparency, and data protection in all stages of data acquisition and processing lifecycle. She established the Data Responsibility Consortium and served on New York City's Automated Decision Systems Task Force with an appointment from the mayor. In addition to data ethics, Julia works on management and analysis of preference data and on querying large evolving graphs. I'll leave everybody's degrees aside. You can see those if you want to look up their bios online. Julia, you are welcome to share your screen and kick us off. Thank you.
Thank you, Melissa, for the kind intro. It's wonderful to be here. Let me share my screen and please confirm whether you're seeing just my slide or also the notes.
We can also see your notes.
What about now?
Perfect. We can just see your slides.
Okay, wonderful. So once again, a pleasure to be here. As Melissa said in her intro, I am an assistant professor of computer science and engineering and of data science at NYU. And I also direct the newly established Center for Responsible AI at NYU. And my work focuses on several areas of data management, including querying billion edge graphs that change over time, and also including preferences and voting, especially in presence of incomplete information. But the topic that's most relevant for today's panel is my work on responsible data science. So what is that about? I interpret responsible data science as incorporating ethics and legal compliance into data science systems. One of the terms that is most often encountered when we talk about responsible data science or responsible AI is bias. And there is, of course, a lot more to responsible data science than bias, but since I only have 10 minutes today for my remarks, I decided to focus on this dimension specifically today. So let's unpack the meaning of this term. What is bias? And for this, I will get some help from Batya Friedman and Helen Nissenbaum, who in 1996 published a seminal paper called Bias in Computer Systems. And in that paper, they characterize, or they give us 3 types of bias that can arise in computer systems. And I represent these as a 3-headed dragon. Pre-existing is one head, the other is technical, and the third is emergent. Pre-existing bias exists independently of an algorithm, and it has its origins in society. Technical bias is introduced by the operation of the technical system, and it may exacerbate pre-existing bias. And finally, emergent bias arises in a context of use. And it's due very often to the operation of the technical system and to the impacts that it has on the world. So let's discuss these 3 types of bias in turn very quickly. Pre-existing bias is essentially synonymous with bias in the data. Data science systems, of course, critically depend on data. And those among them that use machine learning are trained on data. As we know, they learn to predict patterns about the future based on the past that this data encodes. I like to invoke the following metaphor. Data is an image of the world. It's mirror reflection. When we think about bias in the data, we interrogate this reflection. One interpretation of bias in the data is that the reflection is distorted. We may systematically oversample or undersample particular parts of the world in the data, or we may otherwise distort the readings. To illustrate this, I will invoke an example from the domain of algorithmic hiring. As you may know, algorithmic tools, predictive analytics, are used more and more today to decide whom to hire and whom to promote and to whom to give a raise at companies. So consider a resume screening tool that aims to predict whether an applicant will do well on the job at a technology company. Such tools are trained using historical data. And that would be resumes of people who were hired in the past at this company or at other companies in the technology sector. And that training, of course, was subject to pre-existing bias. In the data, there is, as far as we know, an underrepresentation of women in the workforce, and in particular in the technical roles, and also an underrepresentation of individuals who are not white. A more subtle point is about distortions in the data. When we consider features like an individual's score on a standardized test, do we take these features and their values at face value? Or do we account for differences in access to educational opportunity, like going to a better school or having access to paid tutoring? Another interpretation now of bias in the data is that even if we were able to somehow take a perfect reflection of the world in the data, it would still be a reflection of the world such as it is today, and not necessarily of how it could or should be. And a couple of important points here based on this mirror metaphor are that, first of all, the reflection cannot know whether it's distorted. That is, data alone cannot tell us whether it's a distorted reflection of a perfect world, a perfect reflection of a distorted world, or if these distortions compound. And the second point is that it's not up to data or algorithms, but rather up to people, individuals, groups, and society at large to come to consensus about whether the world is how it should be, or if it needs to be improved. And if so, how we should go about improving it. On to the second type of bias now, and that is technical bias. It's concerned with whether our modeling, algorithmic, or other technical choices introduce or amplify disparities in the data. Algorithms model the world, as we know, and that means that they take complex and often unmeasurable concepts like success or risk, or maybe something seemingly more simple like disability status or race or gender, and then they simplify them. And so when we think about AI, when we interrogate how concepts are modeled and why they are modeled in this way. There are inevitably trade-offs, And we need to think about what the costs of a particular modeling choice and of particular trade-offs may be. Technical bias can arise in complex data science pipelines. If we are not being thoughtful about our modeling choices, and if we don't account for a variety of objectives, not just efficiency of some sort or accuracy of some sort. So let me give a very quick example here. Consider Anne, a data scientist in a human resources department at a large retailer. Anne was tasked with developing a model that predicts the level of compensation to offer to successful job applicants to make sure that they are indeed successfully hired. Anne is going to include candidates' self-reported demographic data together with their employment histories as input. Following her company's best practices, she will split her data sets into training, validation, and test. She will then implement data pre-processing of various kinds. She will join some tables, then she will interpolate missing values, and then perform model selection, and finally tuning and validation. And next, Anne will consider the accuracy of the trained model and observe a disparity, namely that accuracy is lower for female applicants and particularly for middle-aged women. And this represents a kind of a fairness issue as well. Considering the complexity of the data pre-processing pipeline, Anne likely has a long night of debugging ahead of her. But she has a hunch. She goes back to the data pre-processing steps and observes that the value of the attribute age is missing far more frequently for female applicants than for male applicants. Women don't like to disclose their age. And so she interrogates how missing values are interpolated. She compares age distributions by gender and notices differences starting from the mid-30s. She revisits the data cleaning step and selects a better data imputation method than the default that she was using, which was to take the mean value, to fill in age in applicants' demographics. This example illustrates a more general issue, and that is that incorrect or incomplete choices during data modeling or data preparation can introduce systematic distortions in the data, affecting performance for particular groups. Other examples include systematically guessing a person's gender incorrectly, because values for gender may be missing more frequently for some demographic group, for women, than for another. And importantly, it's been documented that data quality issues, such as missing or dirty data, disproportionately affect members of historically disadvantaged groups. And so we risk compounding technical bias due to data representation with pre-existing bias for such groups. Finally, very quickly to talk about emergent bias, and that is the unintended consequences of data-driven systems once they are deployed. Examples of emergent bias are various feedback loops that the use of data science systems can introduce. One prominent example is the use of predictive analytics in hiring once again. And this is because humans trust machines. A human resources manager who uses a biased resume screening and ranking tool that consistently returns applicants who went to a handful of selective schools, Ivy League schools, for example, at the top of the list, will over time come to believe that this is what promising candidates look like, in fact. So how can we use technology to help fight emergent bias? My thinking around this is about surfacing emergent bias through interpretability and public disclosure. And I like to think about interpretability using the nutritional label metaphor. I'm showing you an example here. Nutritional label is different from some very general forms of metadata. It's specifically aimed at public disclosure. A label should be comprehensible, understandable. It shouldn't be an overwhelming history of every processing step applied to produce a result. It should be short, simple, and clear. A label should be consultative, providing actionable information, not just descriptive metadata. Based on this information, consumers may cancel unused credit cards to improve their credit score, and job applicants may take a certification exam to improve their chances of being hired. Labels should enable comparisons between related products, implying a standard. And finally, they should be composable and computable, derived automatically as data and decisions are produced by complex systems. I will wrap up now. I will only say that the images that you've been seeing in my presentation are drawn from several comic book series that I have developed together with the very talented Fala Arif Khan. I'm showing you here one series that only has 2 volumes so far that is aimed at technical folks, at data science practitioners and students. There's also a course that I teach on responsible data science at NYU with all materials available publicly on GitHub. Please take a look. And finally, we just released a comic book series and also a course that is aimed at members of the general public. It's called We Are AI. So please take a look at that as well. And let me know what you think. Everything is on GitHub. Thank you very much.
Thank you, Julia. That's great. What we're going to do following each presentation, there's a couple of minutes for any clarifying questions, but then we'll take broader questions for the whole panel at the end. Great. So if nobody has any clarifying questions now, I think we'll move ahead to Jim Basney, and I'll introduce him as he's getting ready. Jim Basney is Principal Research Scientist in the Cybersecurity Group at the National Center for Supercomputing Applications. Jim is also Deputy Director of Trusted CI, the NSF Cybersecurity Center of Excellence. Previously, and Jim, I hope you don't mind, I added some of this background here. Jim led the CI Logon project, which enables federated authentication for NSF cyber infrastructure. And he previously served as the security technical lead for Exceed's software development and integration effort. He has worked on additional identity and policy activities at the national level. And Jim, I'll turn it over to you. Thank you.
Thanks, Melissa. Hi, everyone. Good to be with you. CI Logon's not in the past. I still lead it today. So thanks for including the mention of CI Logon. But today I'll be presenting with my Trusted CI hat as Deputy Director of Trusted CI. And so let's start with an introduction to Trusted CI. It's the NSF Cybersecurity Center of Excellence with a mission to develop an NSF cybersecurity ecosystem that enables trustworthy science. And we're a collaborative project across 5 institutions, but the ecosystem is larger than just the 5 of us working directly on the project. And we have a lot of very important partnerships, and I'll try to highlight in my short presentation areas where partnerships with research facilitators are really key. So thinking about ethics in research computing, there are 3 examples in the cybersecurity area, one fairly recent, 2 that are older, but that are still relevant and still impacting our research computing environments today. So the recent one, probably most of you saw some news headlines about it, was a study about how malicious contributions to the Linux kernel or flawed contributions to the Linux kernel are handled by the maintainers of the Linux kernel. And so that experience, that example really illustrates the value of working with the institutional review board. And for us, for those of us who are computer scientists, making sure when we tell the institutional review board that our research is exempt, that there's not an impact on the research subjects, that we're giving the IRB all the information they need to make a good judgment about the research that we're doing. In this specific example, there were impacts on the Linux kernel maintainers in dealing with these patches that I think were not foreseen by the IRB in that case. So that example is really working with the IRB and having a good informed dialogue with the IRB about the research is really key to good practices. A second example is something that continues to occur in our environment, is cryptocurrency mining in our research computing environments. And a very prominent example of that was in 2014, there was Bitcoin mining by a user on NSF-funded supercomputers, and that researcher ended up being banned from NSF research funding and use of NSF-funded computing for a period of time. So that certainly has can have impact on the researcher, impact on the facilities and the environment. And so cryptocurrency mining is definitely an ongoing issue in our research computing environments. And the third deals with regulated data. And we still do refer back to a case in 2009 where a professor was prosecuted and found guilty of violating data regulations, in this case, ITAR regulations. And so when we think about what are the impacts of these data regulations to our campus, is it going to result in a fine? In some cases, it does result in very serious impacts on the researchers. So then looking at the topic of privacy, data privacy in our research environments, I think about how we're seeing a change in our ransomware threats, where previously we thought about ransomware as being an attack on availability. The ransomware gang encrypts your data so that you don't have access to it anymore. And so it's important to have backups to that data so that you can restore and recover. But now the ransomware gang, some of them are threatening to publish sensitive data that they obtain as part of their attack on the system. Here's a quote from an example at the University of Colorado and University of Miami, student and patient data being involved. And so not being prepared to defend against ransomware attacks could have implications for the privacy of sensitive data that's being used in research on campus. Also very interesting ethics impacts or ethics questions related to ransomware. Some universities make the decision to pay the ransom, others have not, but you think about paying the ransom is in some way funding or and directly funding future attacks on our infrastructure. So one pointer I'll give is to a report coming soon out of a collaboration between Michigan State University and Trusted CI that's looking at the threat of ransomware to the open science community and giving some lessons learned from the experience of a ransomware attack at Michigan State. So I think as in cases where our research infrastructures, our university cyber infrastructure operators are willing to share these lessons learned and share their experiences, that helps us all. So thinking more about the sensitive data that we use in our research that is potentially subject to attack, we can think about examples like personally identifiable information, protected health information, controlled unclassified information. And these examples and others are covered in a report from my colleague Sean Peisert on the Trusted CI project. He and his team did a set of interviews in 2020 about research practices supporting sensitive data. And they have produced this report with recommendations that I recommend taking a look at, including the value of a good data management plan that documents how you're handling sensitive data from this, in your relationship with your research sponsor, and also data use agreement, how you're working with sensitive data provided by a data provider. And sensitive data is one aspect of the trustworthiness of the data that we use in our research computing environments. And we had a working group, Melissa and others on the Zoom call today were involved in this working group looking at trustworthiness of scientific data. We did a survey that found that researchers agree trustworthiness of scientific data is important. It impacts the reputation and trustworthiness of the scientific results, the reputation of the researchers, and integrity of the scientific process. But there are questions of who is responsible for the trustworthiness of the data, the infrastructure that hosts the data, the researcher doing the research. And I think the outcome is that it really requires good communication and everybody working together in their roles. And so we produced a report with recommendations looking at how people on campus in different roles help to break down barriers to trustworthiness and make sure that researchers know about the available tools that they can use to maintain the trustworthiness of their data, maintain the privacy of their sensitive data, and the research facilitator being a really key role on campus, helping researchers know about the resources that are available for trustworthy data backups, for capturing metadata and publishing data in trustworthy repositories. And so I hope that in my brief remarks, I've illustrated how privacy and risks are to our scientific process and our data. It really relies on good cybersecurity on campus and good cybersecurity with our campus research resources. And so I do recommend taking a look at the Trusted CI framework that gives recommendations across multiple aspects of cybersecurity on campus for research computing, including the value of having your cybersecurity aligned with your mission to support research, having clear who's responsible for different aspects of your operational cybersecurity, having effective resources, including people and tools to support your researchers' cybersecurity needs, and good cybersecurity controls to maintain, for example, the privacy of your sensitive data. So with that, I'll acknowledge our support from NSF and my fellow team members on Trusted CI, and refer you for more information to trustedci.org. And I look forward to our discussion. Thanks.
Great, thanks very much, Jim. I will pause a moment for any clarifying questions. Okay, great. All right, so now we're going to move on. We have an actual lawyer on our panel today, which is great, and we don't often have that opportunity in these kinds of workshops. So I'm pleased to introduce Mark Potkowitz, who is director of the Legal Innovation Center at Ulster University and the course director on corporate law, computing, and innovation at the master's level there in Ireland. I think he's actually based here in the States at the moment, and he is a licensed attorney and previously served as adjunct professor of clinical law at Brooklyn Law School, where he was the director of policy for the Center for Urban Business Entrepreneurship and the Legal Technology Fellow. Welcome, Mark.
Thank you very much. I'm thrilled to be here today. I'm glad that so many illustrious panel members have been able to join and speak to a wide range of issues. And hopefully we'll be able to bring some clarification to some of these complicated legal matters that we may become embroiled in. Now, this is where I have to say that none of this is legal advice. And of course, my views are my own, and I'm not representing those of my institution. So one of the things that I'll just begin with is saying that when we think about notions of privacy, and I apologize in advance, my students note that I tend to go on, and I really do enjoy the history. So I'll try to keep this brief. But when we think about notions of privacy, the original way that privacy was envisioned was in the idea of trespass. So in the olden days, before a lot of the technology came into place where we could kind of solidify things into a medium, the idea of privacy was based on maintaining dominion over your property. So the only way that somebody could invade your privacy would be maybe to peep into your windows and to be on your property. So this was tied to a notion of physical trespass. As we move forward with the development of technology, and we could fix things to a medium like take a picture or take an audio recording, new ways of invading privacy became available to people at large and to government. So in broad strokes, as we continue along with the path of developing technology, we find new ways that privacy can come into play. So a lot of the laws have yet to catch up with respect to some of the types of things that we see regarding how privacy can be invaded by technology. Certainly things like machine learning give a sort of new ways that people can garner private information about us. So certainly with respect to the legal regimes, we have a lot of interesting interplay here regarding the types of rules that we might want to consider. So researchers involved in collecting types of information, such as what we would call personally identifiable information in the United States, could run afoul of a wide range of legal matters. You have state law issues in places like California with the CCPA. You have federal law issues like the Children's Online Privacy Protection Act, FERPA, HIPAA, and a range of others. And we now have international legal matters, such as the General Data Protection Regulation. I'm not going to speak to each of these on an individualized basis because the types of things that can come into conflict are highly specialized with respect to the types of data that you're using and the way that you're analyzing the data. So what I'm going to try to do is speak in broad strokes with respect to the kinds of things you may want to be cognizant of as you're beginning to get involved in not only the research itself, but facilitating that research. So in general, consent is an incredibly important element here. When data is being collected and when data is going to be used, consent and disclosure around how that data is not only collected and stored, but how it will be used and shared is incredibly important across almost all of these pieces of legislation. In addition, there are good transparency practices that tie into not only how the data will be used and shared and stored, but also, as Jim mentioned earlier, there are cybersecurity components and de minimis standards here and expected to adhere to with respect to the storage of this types of information. Depending on the jurisdiction in which you're collecting the data and where the data subjects may live, other rules can come into play. Some of these privacy laws are increasingly moving toward the ability of data subjects to put in a request for the types of information you have on them. This is known as a data subject access request, or a DSAR, in the European Union under GDPR and other similar legislation with similar language. There are some types of legislation that allow for a right to be forgotten. In other words, data subjects in certain contexts can request and withdraw their consent for data usage and request that that data be deleted. There are other instances where, with respect to these data subject access requests, you may need to disclose how you're using the data specifically and with whom it's been shared. Now, even if you're not the person who's collecting the data or conducting the study, if you are going to be storing some of this information or some of this data on your facilities, some of these laws could attach to you in an extraterritorial fashion. In addition, depending on the types of manipulations you're doing on the data, you may be required in certain contexts to describe how it is that you're doing this. Another general principle with respect to these types of data laws and privacy laws is the concept of minimization. This is the idea that you are taking steps to ensure that the information that you're collecting is sort of the bare minimum that you need in order to achieve your stated goal. And that in your data storage and data sharing practices, you are not sharing the data or putting it in places beyond what is absolutely necessary to achieve that stated goal, tied to the specific consent of the person who gave you information. So I know that that's sort of a lot of things going on, and I know that we're typically doing general questions at the end of the small presentation, but as people are letting that sink in, before I move on to some of the next things, I thought I might open the floor to see if anybody has any quick questions on those or if I should clarify any main points. So as people are typing in the chat box, I'll move on to a few of the other things that I've noted here. So in addition, Jim brought up ITAR, which is the regulations regarding international arms trafficking. There are certain types of information and certain types of components that could fall into the ITAR classifications, which deal with the Department of State. There's also the BIS, and I forget what that stands for, in the Department of Commerce, which deals with ECCNs, or Export Control Classification Numbers. So there's just been a question about export control with DOE. I'm not as familiar with the DOE rules, but certainly I think that the ITAR and the ECCN, the classifications under the CCL list with the Department of Commerce, fall into that as well. So certain types of encryption technology, for instance, fall under these ECCN classifications and historically have been problematic. So this all isn't to say that you should be incredibly deeply focused on all these legal issues. If we listen to all the lawyers, nobody would get anything done. And frankly, a lot of this stuff is incredibly nuanced. Harry Truman famously once said, give me a one-armed economist so they can't say on the one hand, but then on the other. But unfortunately, lawyers are trained to be the worst case scenario thinkers. And if we let people be petrified by all the possible things that can go wrong or all the possible things that can come into play, nobody would get anything done, like I mentioned before. So I'm bringing in a lot of these issues for people to be more cognizant of the types of things they may want to think about when they're putting these projects together or facilitating them. The kinds of questions you might want to ask with respect to the type of data that you're going to be handling or the type of data that you're going to be collecting. You may want to be concerned, and I think that those frameworks are a great start with respect to the idea of cybersecurity. That's an incredibly important thing that I think a lot of people ignore. to get a good sense of where the data might be stored and where it might be held, to get a good sense of how the data is going to be used and whether it's tied to specific consent or disclosed to the data subjects who shared it in the first instance. Another thing that's important to realize is that there are different ways that some laws classify the sharing of information. So while there are generally public interest exemptions or exceptions to the types of stringent data processing rules that I've just mentioned, depending on how the data is transferred, it might be considered a sale. So for instance, in the recent California rule, any consideration, which would be exchange with respect to the sharing of data, could take that data from a research kind of sharing relationship to a data sale under the California law, which have other strict requirements come into play. So I guess this is just a big plug for being aware at the initial instance of some of the legal matters that you may encounter, so that if they do come up, you'll be better prepared to handle them. Now, the last thing I'll say here, and again, this is not legal advice, but from a normative perspective, some of these are decisions where you need to consider how to tackle these matters with respect to achieving your research aims. So in other words, when it comes down to ensuring that you're doing everything properly, which is incredibly important, to be cognizant of the amount of time you spend considering all these externalities that may come into play and whether or not it's going to have a negative impact on your overall research aim before you even begin. So I'm generally very bad on time. I could go a little bit longer.
Nope, I think we're good. And I know that I'm going to have a question for you in the discussion time. So I think we'll keep moving if that's okay. So I'm going to introduce, thank you. I'm going to introduce Kendall Rourke now. Kendall is an applied cultural anthropologist and assistant professor of information studies and anthropology at Purdue University. Her research and teaching interests center on data curation for the arts and humanities, participatory and speculative design, critical data studies, and data science ethics. She's PI for the Queer Tech Futures Project. She's developed, and through that has developed a series of critical data studies modules, and recently co-led a critical data visualization ethics workshop for the NSF Center for the Science of Information. Kendall, you're welcome to share your screen when you are ready.
Okay.
Oh, I think you are. Great.
And let's see. Am I?
There you are. Okay.
Okay.
We can see you and not your slides.
Okay.
And that's okay too.
It says one participant can share at a time. Oh, I can just
Okay,
change it.
so,
I will change it. Okay, I have it now.
Okay, super.
Yeah. Okay. Thank you for inviting me, Melissa. I am going to present some materials. Let me go ahead and start my time clock because I will go over. Some of which I pulled together for a critical data visualization workshop with my colleague Beatrice Bird at Purdue for the Center for the Science of Information. And I was kind of pulled into this project. I don't necessarily have expertise in data visualization. My background is in visual anthropology. I approach things a little bit differently in speculative and participatory design. But I was asked to work through a data visualization process that students were learning and come up with some insight into critical data studies, applications, and ethical implications of visualization. And one of the things we found after doing completing the workshop and getting feedback, and we had a publication of that, and now we're working on a second one, is that ethics and privacy really need to be embedded into the process from the beginning in order for students to really see that developed and be important or central to their research projects, their team research projects and visualizations. And so so something like accessible design and like creating a visualization that is accessible in terms of, say, an example that came up in our workshop for colorblind, those who may be colorblind, that was very easy for students to tackle. And that's how most of them chose to actually focus on the materials. And even though we had spent a lot of time really working through trying to understand the provenance of data, thinking about stakeholders for human participant data, and really thinking about the implications of our visualizations. So that's for my presentation. I just wanted to talk a little bit about that and share some resources that may be interesting and maybe some questions that I'm also a research data specialist at Purdue in addition to being professor. So I do handle workshops and work with other researchers as well and students. So I have a couple questions that might be helpful when working with researchers to think through that process as someone providing a service as well. So the first is just this idea that there is a need for new ethical frameworks that engage emerging socio-technical issues related to the rise of data science. And that focus on emergent, I heard that from a couple other participants as well, is really important, so that there isn't really one answer. There never is really one answer, but a lot of the ways that we may have been trained even a couple of years ago didn't take into account changes within the larger environment. And that also includes really a shift in the economy towards more data extractive or data surveillance, like as part of a major part of our economies, whether in multiple sectors. And so just the massive amount of data that's being collected about individuals. So the kind of data that we may collect or work with, we have to think about that in a broader context of what else is available out there. So one of the things that we worked on with students was thinking about big data and algorithm ethics and kind of looking through some of the literature on this and thinking about how this applies to our own research, dealing with issues around transparency, fairness, and accountability, but also thinking about participatory and democratic aspects of data and the impact of our visualizations, thinking about justice or social justice. And this came out in some themes around considering disparate impact of our work, thinking about ethical harm, the concept not only of informed consent, but informed refusal as something that we might consider when engaging with, say, a publicly available data set. And some of the things that were mentioned recently in the other talk around right of explanation, right to be forgotten, and then the opportunity for intervention and redress based on those whose data may be included within these larger data sets or data streams. So in order to kind of deal with, what are some new directions, we looked at Floridi and Taddeo's work on data ethics and algorithm ethics as well, and thinking about the impact these significant ethical challenges that are being presented and also with critical data studies. So just this idea of big data collection and use, the complexity and autonomy or semi-autonomy of algorithms, especially around algorithmic decision-making, and then responsibilities and liabilities of those who have some role in the creation and distribution of these data sets or streams, and thinking about data linkage and third-party data that may be available. And then we brought that into this space of thinking about ethical and collaborative visualization design. So bringing from my background in participatory and speculative design, thinking about this from this broader viewpoint of and really trying to embed these questions into the beginning of projects, whether you're at the proposal phase or maybe prior to data collection or use. So looking through Emil, looking at most of the established literature looks at truthfulness and accuracy when we're talking about ethics and visualization. But there are, again, these special ethical concerns also with visualization that we might want to look at in the context of data science and big data. So involving relevant expertise and perspectives into the design process beyond the need for teams or multiple viewpoints to try to understand the impact of work, and especially visualizations, transparency, conveying data limitations, and enabling different levels of engagement with the topic. So these were some of these things that were highlighted in the literature and in this review, but also kind of expanding that, thinking about data and visualization provenance. So these ethical issues that I mentioned surrounding where does the data come from, even if we're not involved in data collection, thinking about informed consent and informed refusal, and what kind of impact does that have not only on the questions or the type of analysis that we can do, but also the broader impact of our work, and ethical considerations, professional and project specific or stakeholder community specific. Other aspects of data production and collection, and then emergent issues maybe surrounding, which we had some discussion around machine vision, and thinking about this in terms of provenance as well, and what exactly are we talking about when we talk about visualization? Is that also changed within this context? So thinking about, in a different way of thinking about responsibility and attribution when machines are involved, thinking about the tools that we use as well and their provenance. So a question that came out of this is, what are the implications of utilizing data collected via an ethical, which is maybe project specific or community specific concept and values, or through extractive data collection practices, and really trying to, so one of the ways I bring in participatory and speculative design is having a research team think through, the provenance of that data using tools like methods like commodity chains. So thinking about data as a commodity and like who are all of the stakeholders that might be affected, and also how this might, it's an iterative process, and thinking about how that might also feed into these networks. And then really specific, thinking about, changes in terms of privacy and confidentiality in our visualizations, especially, students and teams have been interested in issues around geoprivacy, spatial confidentiality, and just being aware of updated work and concerns that are being brought within the current literature, trying to bring in people who are working in these spaces, but also realizing that they don't necessarily have the answer, but that that we can think through some of these issues that may not have been part of our training even a couple years ago. So a question here, thinking about privacy and confidentiality, preserving techniques for geospatial data. So how can we preserve confidentiality of a person's location while still being transparent about the research process as possible? And I think that we're seeing some really interesting public debates right now around this with the census, and there are, thinking about different approaches. So how do we actually get to thinking about involving stakeholders and making in collaborative and participatory? First, we have to maybe identify who those are, and those were these mapping kind of projects or workshops can be helpful, but also thinking about, using different approaches to look at our data and our visualization. So drawing on work like from Hepworth around empathetic visualizations, Ignazio's work on creative data literacy. We have examples from DeSalvo on speculative visualization, who also talks about an example of agonistic visualization, which I think is really interesting for interactive visualizations, where you're thinking about how do you look at different views into data, into presentations, and thinking about those within these broader contexts so that we can present, not because of the rhetoric of visualization, that it can have this impact where, and there are many studies on this, where you're looking at sort of the influence or the sort of shutting down other possibilities for viewing of data through the visualization process. So how might we, through interactive and provide these agonistic kind of approaches so that where you're seeing different interpretations or views into data. So that's part of that process. So I probably put too much in once, so I didn't really get to talk about it. I think so we have a panel, but I think part of it, just the work I'm doing is just trying to work with students and teams and other research just to kind of think about what are the implications of their own, the context of their own work and visualizations, and where does this, pay attention again to provenance. And my light went out. Have that as a starting place and getting more involved at the beginning or having teams get work through some of these issues, not at the end of the project or before the presentation or something like this. So, okay, thank you.
Right, thank you so much. And your last point there, I think, is key, and something I'll bring up when we get to the discussion a little bit more deeply. And that is that research facilitators and advanced computing services often are not part of projects at the very beginning, potentially, particularly with students who come with a formed idea and say, hey, I need help running this algorithm, or I need help running this pipeline. And I think when we get to the discussion, one of the most interesting things is how do we think about those decision points that research facilitators need to make to support storage, pipelines, workflows, and cybersecurity for projects that are coming fairly well formed or even already funded, and how do we help them make sure that they're making the best decisions in terms of cyber infrastructure and computing that meet the responsibilities of ethical and responsible research, while we're also helping them meet their aims. Okay, and now it's time for Tanya Berger-Wolf, who is professor of computer science engineering, electrical and computer engineering, and evolution, ecology, and organismal biology at Ohio State University, the Ohio State University, where she is also the director of the Translational Data Analytics Institute, TDAI. As a computational ecologist, her research is at the unique intersection of computer science, wildlife biology, and social sciences. She creates computational solutions to address questions such as how environmental factors affect the behavior of social animals, humans included. Berger-Wolf is also director and co-founder of the conservation software nonprofit WildMe, which is home of the Wild Book Project and brings together computer vision, crowdsourcing, and conservation. Her bio's available, as is everybody else's, on the web. I'll make sure to dump them into our shared notes as well, and or add them into the shared notes. And I turn it over to Tanya now.
Thank you, Melissa. And I'm going to talk a lot about the same kinds of issues, but from slightly different perspective, maybe. So because, as pointed out in the biology, I work in conservation and ecology. But first, so yes, among the many hats I wear, I'm a director of the Translational Data Analytics Institute, TDI. It is a large interdisciplinary research institute at The Ohio State University with the mission of creating a community of excellence in data-centric, translational, and interdisciplinary research, scholarship, and creative expression with impact in society, and will bring together more than 200 institute affiliates and work to build a community internally and externally with partnerships across the globe, actually, and also focus on research, education and outreach, building capacity, and providing services. Back to AI. Well, if we're talking about ethical and the issues of ethics and governance in AI and data science, we have to take a look at the discipline as first as a whole. So if we look at who does AI today, this is the picture. And whether you look at any top 10 AI researcher list, or the people who actually sit in front of the computer screens or publish the papers, the picture is pretty much the same. It is highly gender skewed, and the work is concentrated in very few countries. So this is the publication by country in AI, publication lists in AI by country. And it is problematic because because the discipline is global and it's intrinsic in many societal issues today. And we're creating not only on a national scale the divide and the imbalance, but also on the international scale. So the distribution of all the resources from cyber infrastructure, and that drives also this kind of imbalance is a cycle that drives the distribution of cyber infrastructure, everything from cyber infrastructure to the outcomes and the brains and the intellectual capital and the economic impacts and the policy impacts. So a little bit of the context for why my perspective is maybe sort of this, all the issues that have been discussed so far by the 4 previous speakers. Here's a little bit of a different perspective. I work in this particular case study I will present. This is in conservation. So starting from research, and there's very much hand in hand the research that I do, and then a nonprofit WildMe that I co-founded. So one of the main projects of the nonprofit is the project Wild Book, and Jim and Melissa both know very well, where we, using artificial intelligence, machine learning, and computer vision, built a platform that is capable of taking millions of images from any source, whether it's scientists, conservation organization, drones, camera traps, or tourists going on the vacation watching whales, swimming with sharks, or taking photographs of zebras and giraffes, posting it on social media, or directly uploading and giving it to citizen science. And so using AI machine learning, we can take these millions of images and automatically find all the images that contain animals, find where the animals are in those pictures, put a bounding box around them, and identify not only species, as in elephant, humpback whale, hawksbill turtle, or greater zebra, but down to individual animal, as in Zippy the zebra, Joe the giraffe, Terry the turtle, and Willie the whale. And so then with information on when and where the image was taken, you can really build this massive platform and track animals, count them, and even build their social networks just from the pictures that we're taking. This is a huge asset for science and conservation. Using this platform, so this is an example of one of the wild books. This is for whale sharks. Just from that platform, from the data from that platform, now has become the official data for the International Unit for Conservation of Nature Red List, which is the organization that officially tracks biodiversity of the planet and determines conservation status of the species. Using that data, the global population size of whale sharks was determined. Using this data, the conservation status of the species was changed from vulnerable to endangered, and from the population trend from stable to decreasing, not because the species are doing worse, but because we have data on how they're doing. We now know better. And that means very different allocation of resources, policy, and monitoring regimes. The most comprehensive study on biodiversity, on the biology of the species, was also published using that data. So that matters. What and we have more than 60 species now, actually, that's a bit out of date, platforms for more than 60 species, from marine to terrestrial, across the entire planet, and many science publications that have been published, and many organizations like WWF, NOAA, BOEM, and Conservation International that are using our platform, and the data coming from it as the official data source. So what, right? What are the ethical and data responsibility implications? Well, first of all, this is a global project. And so in general, ethical and responsible AI and data science has been already pointed out. So one aspect that we didn't talk is, and it is an ethical aspect, that to build ethical and responsible data science, we really have to talk about inclusive and collaborative partnership. We have to change how the solutions are created, not for those whom they benefit, but with them. And particularly something that affects policy, right? So there is a tendency right now, and this is an issue of global AI and data science, right? Because it is global, the tendency now is that data is a resource to be mined, to be extracted from a country, from a region, from a population, from a demographic, and humans are becoming data points for the benefit of companies or other countries. That is unethical. That does not benefit. We tell that the job the job decision algorithm, the job position decision algorithm, or the loan allocation algorithm benefits applicants, but it doesn't. It benefits the banks or the companies, and humans are becoming data point. And at a global scale, countries are becoming data points, and countries, the resources like data become mined. We need to increase the diversity of data science and AI itself, and build a global capacity to counter that. The issues of transparency and accountability, in order to be able to examine the biases and the implications of these biases in AI, and the implication both from data to algorithmic and decision making, we have to really, where possible, and it's not always possible, but where possible, open source and open process, and there's a focus on explainability of why that decision was made, right? With clarity of assumptions, uncertainty, and limits, when based on the population size. For example, the entire conservation policy for a species is changed. We've had events where every gray zebra in Kenya was counted using hundreds of people just driving around taking pictures of these zebras. Kenya Wildlife Service took the outcome, examined the outcome, and that was because we were able to explain assumptions and uncertainty and limits around the statement of the estimate of the population size. They were able to take that and change conservation policy and get all 6 governors in Kenya to sign up to that conservation policy, putting money, resources, people, and land. And we have to be responsible for the outcomes because of that, because it affects human lives and the well-beings of entire countries at this point. But what the 4 previous speakers focused a lot is on safety. We talked about, heard about data governance and fairness and bias. I will come back to those 2 issues in a second, but the first one is do no harm. And there's a lot of excitement around AI, but the problem with using AI, and particularly in academic context, it's okay to see whether we can prove on existing solutions. And improving on existing solutions mean improving for the objective, not necessarily just for one step of the objective, just for the algorithm, right? So quite often we can put together 5, 6, and in fact in our pipeline there are 7 different machine learning algorithms. Each one can be 96% accurate for the data that it's tested in the sort of design and academic context, research context. But the overall objective is to estimate population size of, let's say, whale sharks from images coming from a variety of different sources, from scientists to social media. And if all the algorithms put together do not improve on the accuracy of the population size estimate, does it justify using the resources and incurring the cost, which is not only it is in the cyber infrastructure resources such as compute, network, electricity, right? But it is also the environmental cost and the human cost of somebody has to annotate these pictures. And the largest annotation project, annotation factory, is in Nairobi, in one of the worst slums in Africa, which on the one hand, it provides employment. On the other hand, the questions now is what kind of employment. So back to data governance and fairness and bias. So with the fairness and bias, and Yulia talked about the nutritional label sort of and the fairness of the data sets. These quite often are possible when the data already have been cleaned and prepared for machine learning or AI use. Quite often, 80% is going from raw data to that usable clean data, and it's not clear quite often, what is that usable data? So in context of computational ecology and conservation, if we're using images, there is the true population. There are a lot of biases on the way to getting an estimate. There's the spatiotemporal bias of being at the right place at the right time to even take a picture or to see the animals. And whether you're using a drone, camera trap, or a human tourist, all of these incur very different spatiotemporal biases of being at the right place at the right time. The decision to take a picture, or rather the ability of a camera to take a picture, so photo capturing bias, um, and that relies, by the way, this relies on the cyber infrastructure that's available, whether you have the electricity, bandwidth, and the edge devices that are there, or humans to be there to take the pictures, and then to post them on social media or transmit them back to the server. So this is the trade-offs of edge to server cyber infrastructure, the data collection bias from social media or from the edge devices, and then the models that are used to produce that population size estimate. But all we really care in the entire pipeline is the error in the estimate. And so how do we counter that? Figure out the bias? Do we need to figure out the bias? And so, it quite often, and I want to reiterate it, especially for this audience, it depends on the cyber infrastructure that we're using and the cyber infrastructure that we have. And quite often working in uninstrumented environments with edge cyber infrastructure for AI, we're making a lot of trade-offs of which models we're able to deploy and what are the resource constraints for data collection. And the other aspect I want to bring up is data governance. And so while we talk a lot about the privacy and security for human data, in our context, we work with animal data of endangered species. And geotagged, and what's gold for science and conservation is also turns out absolutely wonderful for the poachers and wildlife criminals. So the geotagged images of animals today are calls, really beacons to here's an endangered species. So in our drive to save these species and produce the technology that can do that, we have to be very careful not to not to obliterate the species in the process. So because geotagged images of animals posted on social media are now used by poachers to within hours for poaching attempts. For example, just January 2020, there was a poaching attempt at Kruger National Park, and the elephants, dozens of elephants are killed just in that park alone. Many of them are from social media posts. And so there is today really a focus on what is called termed unnatural surveillance of how do we really scrub the online data. And so Instagram, for example, scrubs geotagging, but it may not be enough. And platforms like Wildbook or there are several others, iNaturalist, eBird, and Wildlife Insights, and many others of similar kind that aggregate the information about endangered species. Not only it is a danger to post this information online, but there is sort of side information, side channels like Strava from the Fitbits of tourists who are going to see these animals, and where they stop indicates location of, for example, a pride of lions or rhinos. There's also huge mistrust because this is a global issue, so there is mistrust between countries on to disclose the information, yet animals are not aware quite often of political borders, and tigers routinely cross between three countries that do not trust each other to even share the information on how many tigers they have, on or whether they have tigers in the region. And so to build a lot of the cybersecurity into Wildbook and in more broadly into our research projects, we had a consulting engagement with Trusted CI, with Jim Basney, and also published a white paper in collaboration with Ross Anderson from Cambridge University, Privacy for Tigers, addressing different issues of obfuscation, cybersecurity, content management, and access control for this kind of data. And with that, I'll end. Thank you.
Great, thank you very much. So we've covered a whole range of material and content here in very different perspectives on a pretty fundamental set of problems. And we only have a few minutes now. We've got about 5 minutes left just for some discussion. And I think the easiest way to do this is to say, I'm going to pose a question, and it's the question I hinted at just previous to Tanya, and ask for sort of bulleted responses from the panelists. And that is, given this fairly broad and high level sort of set of principles, if you will, that we've talked about through the course of these talks today, what are the ways that research facilitators in advanced computing or cyber infrastructure facilitators, data experts, working with faculty, with researchers and students, where can they help in terms of decision points for implementing the computing and the infrastructure to be able to conduct the research? What are those decision points that the facilitators sort of need to be aware of and be able to say, okay, you need to understand this bit of ethics here to help make this decision about the storage, about how the pipeline is tuned, about the cybersecurity that you may need to go back and sort of design a little bit differently. I'll stop there. Feel free to turn all your mics on if you'd like. And Jim, do you want to start? I'm gonna call on, since, oh, Tanya, you're still green. I'm gonna go ahead and come back to you.
In terms of bullet points, so as was pointed out, get in on by Kendall, I believe, that get in on the conversation as early as possible with the researchers, and sort of having that awareness that the researchers might not actually, and quite often do not, understand the cybersecurity risks, constraints, cybersecurity, privacy, and ethics risk constraints and considerations. And so even the conversation of asking what kind of data and what kind of decisions are being made. So going through the checklist to raise awareness at the beginning of the project, I think, is an important part, and also have the consideration of there's the framework now, not who benefits and what are the biases in the benefit or the risks in the benefit, but the harm reduction. So really using the framework of harm reduction in that conversation of what is the potential harm, who would be harmed, and what are the opportunities at all to mitigate that harm, and how do they touch on the cyber infrastructure, and having in mind that a lot of research is global, so having that global perspective is important.
Great, thanks.
Anyone else? I'm happy to hop on.
Great, Mark, go ahead.
So actually, if there's 4 words that I could emphasize here, they are consent, transparency, cybersecurity, and consent. Making sure that you do have very specific, freely given, clear, and unambiguous consent from human data subjects will go a lot to quell a lot of the legal concerns or any issues that the legal folks might cringe over.
So I will add to that as a sort of a related example, because not all research will have human subjects, and so we have that sort of scoped out, and that's great. But we also have a lot of students, for example, and scientists who are scraping the web for data, and this can raise all kinds of problems, because not only because of terms of use and licensing, but because in fact people using particular platforms may not actually know that their data, that what they put there, they know the company that holds the platform might use their data, but they may not be aware that other people are scraping data off the web. So these sorts of questions with people that are doing scraping, particularly around terms of use, is particularly important.
Well, I could quickly add to that too. There was an instance where Watson researchers, I think, had scrubbed Flickr or one of the photo sharing databases to do facial recognition. That can be a huge problem. Clearview AI is another company that's doing facial recognition that's just scraping. and they are going to run into very significant legal matters with respect to those types of things. The other thing is that they're, depending on the type of analysis you're doing on the data, attempts to de-anonymize data, if you have a data set, even beyond just a kind of a security, information security testing thing. Some jurisdictions are looking to potentially criminalize the de-anonymization of data and have certain white hat or disclosure rules attached to if a researcher does de-anonymize data. I know that New York State was considering that at some point as well. So just another thing to be cognizant of, that if you are doing certain types of things that are around trying to de-anonymize information or tag information to particular individuals that isn't strictly in a penetration testing, like information security context, you should be very aware of what the legal rules are that you might run afoul of.
Yeah, and I think too, even beyond that, that if you think about like what would you want, because a lot of these data points are collected through coercive means, it may be the only way that you can access a service as if you sign away or click away all of these rights. So that's something. But I think the other thing is that it's not just about human research participants, but it's also stakeholders. So all of the data that we may encounter, it may have an impact on a social impact, an impact on different stakeholder communities. It could, and that can be so broad, or on thinking about life on the planet in a very broad sense that includes our other so. But what I was going to say is just, I think that really being open to other types of expertise on your campuses or, in your larger, I think some of these issues were brought up for infrastructure on my campus a while back by humanities and social science researchers that had very small, maybe unfunded, grant-funded research. But then I think that if we had, been more flexible and accommodating them, that we would have been able to think through some of these issues. And it may only, I think, thinking about the long-term planning and infrastructure for different kinds of maybe edge cases and designing these systems can be beneficial to everyone potentially. So.
Great, thanks. Julia, I know you need to drop off. Please, yeah, please.
Yeah, thank you. So just to add a very quick comment here, and that is that the systems that we're building are not technical systems. They are socio-legal technical systems. And so when we think about an infrastructure for such systems, we cannot make the social and the educational and the legal infrastructure an afterthought. So cyber infrastructure these days absolutely, for example, must include a large-scale, robust education effort to make it so that we, in fact, are able to draw in voices from a variety of participants, data scientists, citizen scientists, individuals being affected, etc. So maybe I'll just end with that. And please let me know if you'd like to discuss any of the educational materials. I'm very interested in developing more and in co-developing more, so please be in touch.
Super, thank you. We're actually at time. We're a few minutes over. And so I think we need to wrap up. I welcome any final comments from any of the panelists, and we'll end. Okay, it looks like I'll have the, oh, go ahead, Jim.
Well, thanks, good discussion.
Yes, thank you all so much. Really appreciate your time in preparing today and the great presentations. And we've had a lot of discussion in the chat. I'll make sure to capture some of that. And I'm sure people can follow up if they need more information from you individually. Thank you so much. Thanks, everybody.
Yes, thank you all. Let's give our panel a virtual round of applause. This has been fantastic. I think we've learned an enormous amount here. And as always, we've learned just enough that now we can go off and do additional learning on our own. We can never get in 75 minutes. What we actually need, we can only get started down the road we need to travel. So I want to thank everybody, and we are going to leave the Zoom session live. So you're welcome to leave it open on your desktop or on your handheld, wherever you're participating from, or however you want to do it. We are coming back in 1 hour and 25 minutes. and the preview of coming attractions. This is our panel on low-cost solutions for research computing hardware and maximizing value from acquisition. So getting a lot of value out of hardware that either you or someone else has already gotten some value out of, or finding other low-cost ways to provide on-campus, on-premises hardware. So I'm going to go ahead and stop the recording, and we will see you all in 1 hour and 23.5 minutes. Enjoy your lunch.